This experiment is the torsional pendulum. In this lab, you will measure the natural frequency of two pendulums and compare them to their theoretical values. The theory behind this experiment is that if a disc is rotated by a small angle about the axis of the shaft it is hanging on, a torque will be applied to the shaft and set in motion free vibrations. These vibrations will be measured by the strain indicator and sent to the computer. Once you have collected the output, your data reduction can begin. Before we get started on the actual lab, it's important that we know how to practice good lab safety. The first thing to remember is to always keep your finger on top of the shaft of the pendulum. This ensures that no one will get poked while they bend down to work on the pendulum. Second, it's important to note that we need to make sure we stay clear of this connection area between the strain gauge and the wires. It's always a good idea to carry it 6 inches above or 6 inches below the strain gauge area so we keep a good connection. Before we actually attach the pendulum to the apparatus itself, we need to make sure that the apparatus is level. How we do that is by using this little bubble gauge here on the apparatus itself. When you turn the knobs, you change the position of the bubble and the level itself. Make sure that you're using both knobs to ensure that the bubble is as far inside the circle as possible. Once you've leveled it, we can move on to attaching the pendulum to the apparatus. The next step is to make sure that we attach the pendulum itself to the apparatus. Ensuring that we have our 6 inches of clearance, move the pendulum to the apparatus itself, and line up the shaft with the hole on the bracket. Moving it up, we need to make sure that we have at least 1 inch to 1.5 inches of clearance on the shaft, and then to start tightening the Allen key. Once you think it's tight, you can see that there's still a lot of travel in the shaft. So you need to make sure that it is torqued down past what you would normally have to on a normal bolt to make sure that it will stay in place. We don't want any of that travel in our test because it creates a different axis of motion and will throw off our results. The next thing you need to do is, using the long ruler in the lab, measure from the bottom of the plate to the middle of the connection point. This measurement will be used in your calculations later. Now that the pendulum has been connected to the apparatus, there are 4 connections that need to be made from the pendulum to the computer before we can start the experiment. The first goes from the strain gauge to the strain gauge indicator. We're going to set this up in a quarter bridge configuration, which can be found on the back panel of the strain indicator. An easy tip to remembering this is that the red goes to the red, the white goes to the white, and then the black goes to the yellow post of the resistance you're using in your strain gauge. In this case, that's 120. To make sure that you have a good connection, slide the wire through the hole and then tighten it down. Once this has been completed, we need to output a signal from the strain indicator to this analog digital converter box. To make sure we do this with the alligator clips, black goes to black and red goes to red. The final connection goes from a USB from the converter box to the computer itself. Once this has been completed, the only step we have left is to zero our strain gauge indicator, and then we can begin the test. The last step before you can actually start the experiment itself is to make sure that the strain gauge indicator has been properly zeroed. The first step to this is to press the amp 0 button. Looking at the display, you can see how far off it is, and using this amp 0 dial, change either direction depending on what the sign is, to get as close to 0 as possible. Next, hit the gauge factor button. Knowing the gauge factor of the strain gauge is 2, we want to make sure that it is dialed in correctly, as it is shown here. The next thing is to push the run button and use this balance to make sure that the dial, again, is showing 0. This ensures that our readings come from a 0 point when we start the experiment. As the pendulum is moving, we aren't going to get a perfect 0, but as it hovers between positive and negative values, we know that it's zeroed. Now we can start the experiment. To start the experiment, we first need to make sure that the software is up and running correctly. To do this, we will click on the Torsional Pendulum icon here on the screen. As it loads, you can see the visual interface that you will be using to collect your data. The next thing that will pop up is the File Save screen. For this purpose, we will be using the video test file. For your purposes, you will want to label it with the date and the run number and the material of which you're using for each file to make sure that you have good data reduction later. With someone running the computer over there, someone has to be here at the pendulum to make sure that they have the correct amount of torque. What you want to do is find one of the marks on the pendulum itself and line that up with a degree line, any degree line, on the piece of paper below. Then you will deflect or torque the pendulum about 10 degrees to the next line over and let it go. At the exact same time that the person on the pendulum lets go of the pendulum itself, the person running the computer will come over and click this run button seen here. Now, as you can see, the sample time is set at 10 seconds. This means the computer will take a sample of 10 seconds. Once the 10 seconds is up, it will prompt you to save a new file, which you will label the second run of the same material and height with the date. Once you have completed 6 runs at this height, it's time to move on. Once you've completed 6 runs at this height with the steel pendulum, making sure that you have enough clearance between you and the strain gauge, you're going to want to loosen this pendulum and move it up to a higher distance. Once you've gotten enough clearance, tighten it back up and remeasure. Once you've completed 6 tests at this new height, what you will do is you will undo the steel pendulum and bring in the aluminum one. You will do the exact same process for the aluminum pendulum as you did for the steel. That means disconnecting all of your connections and rebalancing the strain gauge indicator for the aluminum. Once this has been completed, you are done with the experiment. Make sure that you have disconnected and turned off all the electronics and start your data reduction.